everyone, and welcome back to another exciting adventure through mathematics. Today we're going to talk about adding and subtracting polynomials. Now this is going to kind of change our focus a little bit from looking at patterns and identifying what type of functions we have to something that's a little bit more analytical, but you'll see in Unit 2 how that all ties together. So again, we're going to be talking about adding and subtracting polynomials, but first we have to define what a polynomial is, right? Make sure you're taking good, clear notes. You got your title, your essential question, your body of notes, your summary, all on the right-hand page, and then on the left-hand page, you're putting your practice problems and things like that. Make sure your examples are on the right-hand side, right? Anyways, our objective today is I can simplify an expression and determine if it's a polynomial, which implies you have to know what a polynomial is. So a polynomial is a sum of exponential expressions. Exponential expressions that have whole number powers. Now you go, okay, I don't know what that means. I don't know the meaning of that. Well, that's why I'm here. I'm going to explain it to you, okay? Exponential expressions implying that we have something raised to something else, where the exponent is a whole number. So here's an example of a polynomial. 6x squared plus 4x plus 16 is a polynomial because, let me bring this up here, because we have whole number exponents. Well, you can see the whole number there. What's the exponent on this x? The exponent is a 1. Just because there's a 1 there, we don't have to write it down. Now in this guy, we could also say this is x to the 0 power, because remember, x to the 0 power, anything to the 0 power is 1. So 16 times 1 is 16. So we don't have to write x to the 0 power. But you can see that all three of these terms have whole number exponents, okay? So that is an example of a polynomial. A coefficient, lots of terms today, okay? So be patient with this. A coefficient is the number that's in front of the variable, essentially, the numeric factor of a term. So when we look at, for example, the 6x squared, the coefficient is the number that's in front of the exponent. So the coefficient is 6. I gotta minimize my little screen here. 6 and 4 in this case, because we have a whole number in front of this variable here. So 6 and 4 are our coefficients, the numeric factor of the term. A constant is a numeric value that we are adding to the end of a polynomial or the end of an expression, okay? The term with just a number. So in this case, we can see that this polynomial, the term with just a number is 16. So our coefficients are 6 and 4, and our constant is 16. Just be familiar with that terminology, so when I use it, you go, okay, I know what he's talking about when he says the coefficient and the constant, okay? So, like I said before, the constant can be written as 16x to the 0, because x to the 0 is 1, and 16 times 1 is 16, okay? Here's something else we would use. The degree of a polynomial is the highest power or the greatest degree of any of the terms. So in this case, we can see this has a 2 as an exponent, this has a 1 as an exponent, and this technically has a 0 as an exponent. So the degree of this polynomial is a second degree polynomial because the highest power is 2, second. Okay? And then the last term for this slide is standard form. What is standard form? Well, we want a common way of writing our polynomial expressions, or any expression really, so that we all can work with the same type of thing as time goes on. So when you hear standard form, and when you hear write your answer in standard form, that means that we are writing it so that the highest power is first, and then the next highest power, and then the next highest power. The way we say that is the terms are written in descending order according to their power. So, for example, the 6x squared plus 4x plus 16 is already in standard form because the highest power is 2. The next highest power is 1, and then the next highest power is 0. So we wrote it in descending order from biggest to smallest. Not the coefficient's biggest number, but the exponent's biggest number. All right. So let's go ahead and take a look at some practice problems here and see how we fare with them. It says determine if the expression is polynomial. If it is, write it in standard form and identify its coefficients. So remember to go back to those terms and understand what those terms mean, and then you can answer these questions. Now notice this is practice, so it should go on the left-hand side. You guys go ahead and try it, and then when you're done, push play and compare your answers to mine. Okay, for number 1, first question, is it a polynomial expression? Is it a polynomial expression? Well, we can see that the exponent here is 1, the exponent here is 3, the exponent here is 5, and 2. These are all whole number exponents. Therefore, it is a polynomial. So we'd say for number one, we're going to say it is a polynomial. It is a polynomial, or yes, I guess, if you want to shorthand it. It is a polynomial. Forgive me, my camera's a little blurry here. And then the next question is, if it is, write it in standard form. So standard form, remember, is writing it so that the highest exponent goes first. So the highest exponent in this case is going to be the 5. So we're going to write that down first. We're going to say that's 1/2 x to the 5th. Okay, so that term's first. What's the next highest exponent? Well, the next highest exponent is the 3. So we're going to carry that down. So it'll be minus 4x cubed. And then the next highest exponent is the 2. So that'll say negative 6x squared. And then the next highest exponent is going to be the 1 here. So that would be plus 7x. So that is standard form of our polynomial. And the last question it says is, well, a couple more things. It says identify its coefficients. So the coefficients in this case, coefficients are going to be the numbers in front of the variables. So our coefficients are 1/2, -4, -6, and 7, right? Those are our coefficients. And then our constant, remember our constant is the term that has no variables in it. It's just a number. So we can see in our case, we don't have a term that has no number or no variables in it. They all have variables. So we don't have a constant, or we could say our constant is 0, because if I add 0 to anything, I don't change the value. Okay, so that's number 1. Oh, it also says determine the degree. Well, this is the highest exponent here is a 5. So we would say it is a fifth degree polynomial. Okay, so that's the answer to number 1 in its entirety. Number 2, first question, is it a polynomial expression? Well, again, polynomials, all whole number exponents. You can see that this exponent here is a 2/3. That's not a whole number. So this right here tells us it's not polynomial. So number 2 is not polynomial. And then we're done with that, because since it's not polynomial, we're not going to write it in standard form or identify any of the other parts. So we're done with that problem. Number 3, we got a little application here. The first thing we have to do is identify the perimeter of the triangle. So remember, the perimeter of a triangle is all the sides added up. It's the distance around an object. So we would add up all of these 3 terms. This is good practice here. The perimeter is going to be equal to, I'm going to write it as P equals, okay, x minus x to the 4th plus 3x minus 1 plus 2 minus 7x squared. So that is the perimeter. Now, we can answer at least the first question here. Is this a polynomial expression? Well, because we can see in my expression here that all the exponents are whole numbers, right? The exponent here is 1, 4, 1. What's the exponent there? Well, technically that's x to the 0. X to the 0, those are whole number values, and then x squared. So those are all whole number values. This is a polynomial expression. But it's not written in a simplified form. It's not written in standard form for sure, but it's not written in simplified form. So we're going to go ahead and combine like terms, and we're going to talk more about that in a second. But we're going to go ahead and write all this down in order from highest exponent to lowest exponent. So we can see we have x to the fourth here. There are no other x to the fourths. So I'm going to go ahead and underline this. We would write this as negative x to the fourth. Okay. What's the next highest exponent? Well, the next highest exponent is the x squared. So we would carry that down. That's minus 7x squared. And then our next highest exponent is 1 because x to the first. And then we also have a 3x here, so we need to combine those. What is x plus 3x? X plus 3x is 4x. And then we have our constants here, and I'm running out of different colors here, but we have our constants, the negative 1 and the 2. So we can combine those. Negative 1 plus 2 is positive 1. So there's our perimeter expression, What I want to do now is say, yes, it's polynomial. Yes, it's polynomial. Okay, so we've answered that question. Then we write it in standard form. Well, we already did write it in standard form because it's the highest exponent to the lowest exponent. So that's done. And then our coefficients are the numbers in front of the variables. So what's the coefficient? Well, here it's negative 1. Here it's negative 7. Here it's 4. And then what is our constants? Our constants is 1. It's the number with no variables next to it. So that is some examples, some practice problems on just polynomial expressions, what they are, and how to write them effectively. The last thing it asked us to do is identify the degree. Well, the highest exponent is a 4. So this is a fourth degree polynomial. Okay. All right. So that is that. Let's go ahead and go on to what we can do with polynomials and what form of operations we can perform with them. Just going through these answers real fast. Go ahead and shorten this up so you guys can see it a little bit clearer if you need to. So you can see the answers there. All right. So that is our practice for what a polynomial is. Let's go ahead and look at something that you guys should be pretty familiar with, and that's the idea of combining like terms in a sense. Remember, a like terms are two terms or multiple terms that have the same variables and the same exponents. They match. The variables and the exponents have to go together, okay? So an example of this is, let's say I wanted to simplify each of these expressions. In the first one, I have 2x squared y cubed plus 4x squared y cubed. Well, you can see that in the first term here, we have x and y, and in the second term, we have x and y. So far, they look like they're like terms. The second thing is that their variables, their exponents have to match. Well, the 2 is the exponent on the x, same thing over here. The 3 is the exponent on the y, same thing here. So these are like terms because they have the same variables and the exponents match on those variables. So for this one, if I want to simplify this expression, I'm going to go ahead and move on here with my page here. This is an example, so it should be on the right-hand side, by the way. So for A, we've got 2x squared y cubed plus 4x squared y cubed. What I like to do is I like to recognize the things that are alike. So we could say this. We could say that they both have x squared y cubed, right? And so what I'm going to do is I'm going to factor out, is what we'd say. We're going to talk more about factoring in the future. But what's left over here, if I take away or if I factor out the x squared y cubed, well, there's a 2 left over. And what's left over here? Well, there's a 4 left over. So I'll put those in parentheses. This is just an idea. This is to kind of help us understand combining like terms. And so now we can see 2 plus 4 is 6. And then we'll carry down this x squared and y cubed. So this is the simplified form of those two expressions being added up. And we can easily see it. We've got 2 of these guys and 4 of these guys. So how many do we have all together? We have 6 of them. So 6x squared y cubed. Notice the exponents did not change, just the coefficient, just the number in front. Now B is a good example, or I should say a good non-example. Why is that? Because you can see that we have the same variables, x and y. We actually do have the same exponents, but the exponents do not correlate correctly with the variables. Here we have an x squared. Here we have an x cubed. So right here, these are not like terms, which means we cannot combine them at all. And so there's nothing to answer there. That's as simplified as it can get, essentially. Okay. All right. So that is an example. I'm going to have you guys do some practice now. So we'll say that those aren't like terms, therefore it's already simplified. And then let's go ahead and do a practice problem here. It says simplify the following, and these should be a little bit easier for you to do because there's a single variable in each of these. Okay. Number 4, 5x squared minus 3x to the fourth plus x plus 2x to the fourth minus x to the third plus 4x squared. You guys go ahead and push pause. Put this on your left-hand side, see what you come up with, and then come back and watch and compare your answers to mine. All right, for the first one, we want to combine like terms. That means we want to put together the terms that have the same variables with the same exponents. Okay? So we can see that we always go from highest power to lowest power. So we can see the highest power here is going to be the x to the fourths. So we have x to the fourth here. Well, in this case, I'm going to go ahead and write this down. You don't have to write it down specifically this way, but I'm going to do this. I've got x to the fourth as a common thing out of both of those. I've got -3 on one of them and 2 on the other one. So what does that give me? Well, that gives me a -1 x to the fourth. Okay. Let's go ahead and look at the next highest. Well, the next highest is the cube. And there's nothing to combine that with, so we're going to just carry that down. That's actually going to be -1 x to the third. The exponent is, the coefficient is -1. And then the next one is the squareds. So we have 5x squared and 4x squared. So I'm going to go ahead and write that down. If I take the x squareds out, what's left over? Well, in this case, we got a 5. And in this case, we have a 4. So 5 plus 4 is 9x squared. And then in the last case, our exponent is just a 1. So we're just going to carry that down as 1x. So here are the simplified forms here. This guy, this guy, this guy, and this guy. So we're just going to write those in descending order. So it'll be -1 x to the fourth minus 1 x cubed plus 9x squared plus 1x. Now we can call that our answer, but we don't have to put the 1s as coefficients, right? How many x's do you have? Well, you have 1. So you can just say I have x. So we would write this as -x to the fourth minus x cubed plus 9x squared plus x. And that is our simplified form. Notice the exponents did not change values. The only thing that changed were the coefficients in front. So that's the simplified form of that. All right, let's go ahead and take a look at number 5 now. We've got 7 minus 9x squared plus 3x plus 5x squared plus 4x minus 2. Now, for the most part in this class, our focus is going to be on polynomials with the highest exponent as 2. So this is a good example of what you're going to see throughout the year. This is something that you'll see actually more in Math 3, but simplifying it is no more difficult no matter what level you're at. All right, identifying our highest exponent. Well, our highest exponent is the x squared, so we'll write that down, x squared, and we have a -9 and a +5, so that simplifies to -4x squared, so that's the first term. Our next term is going to be to the first power, so those go together there, so that's going to be, we'll put an x here, and then what's left over? Well, there's a 3, and there's a 4, so that makes 7x. Okay, and that's our second term. And then, let's see here. Our last term is going to be our constant. So we have a 7 and a -2. So we would just say 7 minus 2, which is 5. That's our last term. So our final answer is going to be -4x squared plus 7x plus 5. All right, so that's how we combine like terms with higher exponents. So last year, Math 1, you guys were focusing on just combining x's with x's and numbers with numbers, right? Now we add exponents to it. And it's no different. It's just you have to recognize that the x squared is a different term than the x, and so therefore those can't go together. All right, let's go ahead and take a look at the next idea. Now, this is a pretty straightforward idea, I think, adding and subtracting polynomials. Well, adding and subtracting polynomials is just basically doing what we just did. We're going to be combining like terms. We're going to be taking two different polynomials and adding them or subtracting them. So the process, you could say here, is number one, to distribute. So if there's anything to distribute, you do that. And then the next thing is you're going to combine like terms. Okay, so it's pretty straightforward. Here's an example of this. So this will be on your right-hand side. It says simplify each expression. Simplify each expression. Here we've got, let's get this in view, make sure my camera's in the right position here. I'm going to go ahead and make this a little bit bigger. So in A, we have 3x cubed plus 2x squared minus 5x plus 7 in parentheses, and then plus 4x cubed plus 2x minus 3. Okay, so that's our two polynomials. There's one polynomial, that's a third degree polynomial. So is that one, that's a third degree polynomial. We want to add these together. We are adding two polynomials. So the first thing we do, notice it says to distribute. Well, what is the number in front of the first polynomial, in front of the parentheses? Well, because it's not there, we say there's a 1 there, right? And then the same thing here, there's a 1 here. If there was a number there, we would use that number, but in this case, it's just 1. So now we're going to distribute that 1 into each of these terms, okay? So we'd end up with 1 times 3x cubed is 3x cubed plus 2x squared minus 5x plus 7. Notice nothing changed. When I multiply a number by 1, nothing changes. There's a reason I'm doing that, though, and you'll see it in a second. When I distribute the 1 here to each of those terms, I would end up with, again, plus 4x cubed plus 2x minus 3. And then we'll go ahead and combine these. We've got a 3x cubed and a 4x cubed, so I'll write that down. X cubed was taken out, and we're left with a 3 and a 4, so that turns into 7x cubed. That's our first term. Our next term is 2x squared, and that's the only thing we have there, so we're just going to write that down. Our next term is the negative 5x and the positive 2x, so we'll take the x out, and we've got a negative 5 and a positive 2, which is a negative 3x. And then our last terms are our constants. That's a 7 and a 3. So 7 minus 3 is 4. And so we can put all those together, and we end up with 2x squared minus, sorry, I got that wrong. Started off with the wrong one. I've got 7x cubed plus 2x squared minus 3x plus 4. And that is our answer for A. Okay? I'm going to kind of go a little quicker through the second one here. Double check my work, make sure I'm right. I don't want to give you guys false information. That's good. For the second one, for part B, I'm just going to do it on the lesson here. We're going to put a 1 out in front. Now notice, this is a minus sign. And this is why it's important to put the 1 out front. Because you're not just subtracting the first thing here. You're subtracting the entire set of parentheses. So when we put a 1 out front and distribute, the first term's not going to change, or the first polynomial is not going to change. It's going to be 2x cubed plus 8x squared plus 1x plus 10. So that's fine. But when we put the 1 out front of the other one, notice what we're doing is not actually multiplying by 1, we're multiplying by negative 1. So negative 1 times 5x squared is negative 5x squared. Negative 1 times negative 4x is positive 4x, and negative 1 times 6 is negative 6. Then we'll combine like terms. The x cubed is all by itself, so we're going to just carry that down. That's 2x cubed. The next one is the x squared, so we got an 8x squared and a negative 5x squared. How many x squareds do I have? Well, I have 3x squared because 8 minus 5 is 3. And then we have x and 4x, so we have 1x and 4x makes 5x. And then our constants, 10 and negative 6, makes positive 4. And that is our answer for part B, okay, for question B. All right, I want you guys to go ahead and do these 4 problems for me. Pause the video and then come back and see how you did. We're going to kind of go through them a little bit quick. I'm going to minimize my screen here so you can see that whole problem. So go ahead and do these. All right, for number 6, we have 4x squared plus 3 plus x squared minus 3x plus 5. So we're going to put the 1 out front and distribute on all of these. Okay, and so we end up with 4x squared plus 3 plus x squared minus 3x plus 5. Now we'll combine like terms, so we got a 4x squared and an x squared. That makes 5x squared, okay? And then we have a negative 3x, so that's going to be negative 3x there. And then we have the 3 and the 5, that makes 8. So that is number 6, okay? Number 7, it says, what is the perimeter of the rectangle? Well, remember, perimeter is adding up all the sides. Now I notice that this side and this side aren't listed, but because it's a rectangle, this side is going to be the same as this guy, and this side is going to be the same as that guy. So we could write it all out together. We could say 5x plus 2 minus x squared plus 5x plus 2 minus x squared plus 3x squared plus x plus 5 plus again 3x squared plus x plus 5. Okay, so we can see that. I'm going to make this a little bigger so we can see it. Okay, so we can see all of those added together. We're going to combine like terms. There's a lot going on here. We've got a negative x squared, a negative x squared, a 3x squared, and a 3x squared. So that would be negative 1, and negative 1 makes negative 2, plus 3 is positive 1, plus 3 is 4. So we have 4x squared there. And then we have 5x squared, 5x, x, and x. So 5 plus 5 is 10, plus 1 total is going to be 12x. And then our last set is our constants. We got a 2, and a 2 makes 4, a 5 makes 9, and a 5 makes 14. So plus 14. So that is our perimeter. Okay, I should probably check to make sure I'm getting these correct, and I am. So we're good there. Number 8. Number 8, we are looking to subtract. So remember, we have to distribute the ones, and in the second case, that's actually a negative 1. A negative 1, so we're going to put the ones out front, and we'll distribute those in. And so we end up with 1x squared, I'll put a 1 there, plus 3x minus 6, and then in the second one, we got minus 5x plus 6, because negative 1 times negative 6 is positive 6. Combining like terms now, we have only one term with x squared in it. We have one of them, so all we have to do is put x squared. And then we have 3x and negative 5x, so that combines to be negative 2x. And then we have negative 6 and positive 6, which actually becomes 0. So you don't need to put plus 0. You can just leave it like that, and that is your answer. All right, so we are good there. And then number 9, I'm just going to share the answer with you guys, but the work is exactly the same. The answer is negative 5x squared plus 7x plus 5. Okay? All right, we got one slide left to go. The question is, identify and correct the errors when they added these two terms. So notice the way it's written is that these are stacked on top of each other, and we can actually do that. But we have to be careful on how we stack them, because we have to make sure that we are combining like terms correctly. And so what is the error here? Spend a second identifying the error and then push play to find out what that is. Okay? So the error here is that we have x to the 4th and x to the 4th. Those go together. Those are like terms. So we have 1 here and 2 here, so that makes 3. But here's the error. Here's the problem. We have x squared and x cubed that are lined up. Can you combine those? No, you cannot combine those. Those are not like terms because they don't have matching exponents. So this person combined them because 5 and 1 make 6, but they can't do that because the exponents don't match. So that was their error there. They didn't line up the terms correctly. In other words, they didn't combine, they tried to combine terms that were not alike. And there's the bell. And then go ahead and critique this one. Now, this one is a little different here. These are lined up correctly. But since we're subtracting, notice what happens here. When we put the minus and plus 4, technically all they did was subtract the x squared. Then they added the 2x. But when we distribute the -1, they should have been subtracting 2x and subtracting 4. So really what they should have done is they should have put parentheses around this bottom term. Oops. Let's see, they should have put parentheses around, oops, what's going on here? I'm having problems. All right. They should have put parentheses around this bottom term. So it's 3x squared minus x squared, which is 2x squared. Then -5x minus 2x should have been -7x. And then 2 minus 4 should have been -2. So those are the correct answers there. They should have put parentheses around that. I hope you got a good understanding of polynomials and how to add and subtract them. If you have any questions, please reach out to me. Otherwise, I will talk to you later.